Today we are solving the following first-order linear differential equation. So the first step is to put this into standard form. And standard form is as follows. We have dy dx plus 1 plus x over x times by y equals 1. So what I did was I divided through by x. And this is necessary because we need this dy dx by itself. And we have to have the term that is y multiplied by a function of x, and this term here on the other side of this equal sign. So now it's in standard form, and we can go ahead and find our integrating factor. So that's I of x is equal to e to the integral of the coefficient of y. So the function of x that is the coefficient of y. So that is this, 1 over x plus x over x, which is just 1 over x plus 1. So we have 1 over x plus 1 dx. And that continued is e to the power of the natural log of x plus c. And now we're going to make c equal to 0 because it's quite arbitrary. So we can choose c equal to 0. Okay, now what we do is we multiply through by our integrating factor. So we have, or rather we can simplify this integrating factor. So it is e to the natural log of x times by e to the x. And this here is simply just x. So it's x times by e to the x. So now we can multiply through by our integrating factor. And we have x e to the x dy dx plus 1 over x plus 1 times by y times by x e to the x equals to x times by e to the x. Okay, so now if I distribute this x e to the x into this brackets, this is what we'll get. We would get x times by e to the x divided by x, which would just be e to the x, and then plus x e to the x. So I can get rid of this and move this all up to make some space. And we put this in here as the coefficient, the new coefficient of y. We can get rid of that too. Okay, so this is something very interesting because the derivative of y in terms of x is dy dx. And the derivative of x times by e to the x in terms of x, we use the product rule, and we get the derivative of x, which is just 1 times by e to the x, plus x times by the derivative of e to the x, which stays as e to the x. So this here, we notice, is the same as this here. So essentially what we've done is we've found the product rule within our new equation. So what we're saying is that y times by x times by e to the power of x differentiated in terms of x equals that. So we're doing the reverse of the product rule. And then of course that still equals x times by e to the power of x. Okay, so now we still obviously have in mind when we're solving this general solution that we're solving for y. So we need to eventually get to this y. So what we're going to do is we're going to integrate both sides in terms of x. Okay, and now if we're integrating, so first there's a derivative and then an integration. So they both fall away, and we're left with y x e to the power of x. Now this here, we use a integration by parts, and we say we let u equal to x, so du is equal to dx, and we let dv equal to e to the power of x dx, so therefore v must equal to e to the power of x. So therefore we say that this integral is equal to x e to the power of x minus the integral of v du, which is e to the power of x dx. And we know this integral to simply be e to the power of x. And then, of course, we don't forget our constant plus c. So now it's really easy to solve for our y. We just take this across. And what we're left with is y is equal to, now x times by e to the power of x divided by itself is just going to be 1. So 1 minus, and this divided by e to the power of x, the e to the power of x's will cancel, and we'll get minus x, and then plus c over x e to the power of x. And that's the general solution for this initial differential equation. I hope you found this video useful and helpful and also interesting. And if you did, please don't forget to leave it a like and subscribe to my channel. We still have 77 days of the countdown left, so there's a lot to learn and we'll be doing new stuff every day. Thank you.